Hi, I'm an old guy and I do maths. And this is a bit of a headache, this problem. It was given to me by a student, and it's been really fun to solve. I'll say that for it. It took a bit of thinking. What we have to do is find the value of k in these two expressions here, such that expression 1 and expression 2 have a unique solution. Now, what that means is that if we're graphing them, the lines that they generate do this. So a unique solution. They cross at some point. Okay, so what we know is that if the gradients are different, they will inevitably cross at some point. So what we're looking for is where the gradient of 1 does not equal the gradient of 2. However, it's far easier to look for where they would have the same gradient, and then we can exclude the value or the values that would give us that same gradient. So counterintuitively, we're not looking for a unique solution. We're looking for where they have no solution. And once we know where they have no solution, we can figure out pretty quickly where they'll have a unique solution. So let's get to work. Okay. So the first thing that we're going to do is we're going to figure out what an expression for these gradients. So with 1, we have ky is equal to 4 minus 2x. Well, that means that y is going to be equal to 4 minus 2x all over k. And our gradient for this is going to be 2 over k. Have I got that right? Negative 2 over k. Okay, right. So number 2, we'll just give ourselves a bit of room so that it's not too messy here. 2y equals negative k minus 3 into x. So y is going to equal negative k minus 3 into x over 2, which means that with a little bit of work, our gradient here is 3 minus k, the negative times that, the negative times that, all over 2. Now, while I'm at this, if you find this this video valuable, don't forget to subscribe. There's new material coming up all the time on this channel. Okay, so we've got our gradients, and what we're going to do is we're going to equate them. So 3 minus k on 2 is going to equal 2k. Now, what this means is that if we can find where these things are equal, then we're looking at one of two things. We're either looking at them sitting one on top of the other if we graph them, or we're looking at parallel lines. In either case, it's not a unique solution. So as I say, once we find where this is true, we can exclude those numbers, and that is our answer. Right. So a little bit of algebra. 3 minus k times k all over 2k equals negative 4. 2 times negative 2, sorry, that should be negative 2, I beg your pardon, all over 2k times that, all by 2k to get rid of the denominator. And what we get is we get 3k minus k squared plus 4 equals 0. So we've eliminated this denominator. that gives us the negative k squared. That gives us 3k. It's equal to negative 4, so we can bring the 4 across and make this equal 0. And so what we have is we have negative k squared plus 3k plus 4 equals 0. And what we're going to do is we're just going to solve this quadratic, which is pretty simple. So let's do that, give ourselves some room and see if we can get this all on one page. 4 minus k, that's going to give us the negative k that we need to get a negative k squared. Factors of 4 are 4 and 1, and there's going to be some combination of that that gives us 3. So 2 and 2 won't work here because 2 and 2 won't give us 3, but 4 and 1 will. K minus 1. Okay, so 4 times negative, that needs to be positive. Four times 1 is 4. 4 times k is 4k. 1 times negative k brings us back to 3k. K times negative k is negative k squared. So k therefore is equal to either 4 or negative 1. Now we're not done. What we know is that if we put these numbers into our original equations, these original equations up here, then the two lines we've got will either be parallel or one on top of the other, and we don't want that. So in order for them to intersect, k cannot equal these two. And that's our solution. A bit of exciting algebra there, but it's all based on very simple ideas about linear equations. Thank you very much for watching. Hope you found that useful. Don't forget to subscribe. Thanks. See you next time.